In the last video, I introduced what are referred to as oxidation and reduction reactions. In this video, we're going to expand on that idea. And redox reactions are technically what we're going to see are like single displacement reactions. Compared to the double displacement reactions we saw previously, only one ion is moving, whereas before we saw two pairs of ions with double displacement that switched. So a new cation with a new anion and vice versa. But now we're going to see that the ions are going to be displaced or replaced, and then other ions are going to be reduced. So we can take a look here in this first image. We see silver nitrate in solution. So that's what we see on this portion. Oh, this portion here, we have that silver nitrate. And then this wire inside the aqueous solution, that's going to be a copper wire. So what happens over time is that the solid copper is going to be oxidized, and that's going to leave the metal and go out into solution, while the silver ions are going to be deposited and reduced. So that's what we see over here. We see that the silver metal has deposited both in the this expanded image here, this enlarged image, and then the real size. So this was the original copper wire here. And I'll remove that notation. You can see that it's changed color. And the solution has turned blue, and that is the presence of these copper 2 ions in aqueous solution. So copper is a solid, we know has that copper color to it. But then in solution, when they become aqueous, so the aqueous ions over here, those are going to be that bluish color in solution. So what we've done here is we've said that this solid copper has been oxidized or has lost electrons. So we know losing electrons is oxidation, and has gone from a 0 oxidation state to a +2. At the same time, our silver, that the ion is +1, has been reduced. So we have losing electrons is oxidation, and then gaining electrons will be reduction. So we've gone from +1 to 0. So again, both oxidation and reduction will occur at the same time, but spontaneously the reverse reaction, so in this direction, would not occur. So we wouldn't see copper ions able to reduce silver or oxidize silver and become itself reduced. So this reaction would not happen spontaneously, but this one would, this forward direction. So we add copper wire to a test tube, and then we add the silver nitrate, this would happen. But if we had silver wire and copper nitrate, then the reverse would not happen. So let's take a look at how we know which of these reactions will happen and won't happen. So there's a table here that's referred to as the activity series of metals in aqueous solution. So conveniently for us, that's what we're talking about, these displacement reactions in aqueous solution. And we can see that copper is listed here right above silver. So that's why the silver will coat a copper wire, because the silver is more stable, right? It's below the copper on this activity series. So the more reactive or active the metal is, the higher it is on the table. Then we know that gold is luckily for us, fairly unreactive. So it's at the bottom of this table here. So again, the copper is above the silver in the series. So copper metal is able to be oxidized by silver ions, is what that means. And that's where we see the silver ions leading to the oxidizing of the copper. So let's take a look at sample exercise 9 here and see if we can figure out which reactions would happen. So first we're given magnesium and then cobalt to sulfate. So let's see if this will happen and what our products will be. So in part A, we're going to write magnesium here, and I'm going to draw it as a solid because all I'm told is that it's magnesium. So I'm going to assume that it's in a solid form in its elemental state. And then I'm given cobalt 2 sulfate. So I know that this will be the molecular form, the ionic form of cobalt 2 sulfate. What we're going to see is that this will exist as ions, so cobalt 2 and sulfate -2. This is going to be my solid magnesium here. So when they react, magnesium will be reduced by the cobalt, or rather it will be oxidized by the cobalt. So this would be my oxidizing agent. And this is my reducing agent because that will cause cobalt to be reduced. So on the product side here, we're going to see magnesium sulfate, MgSO4, and then we're going to see cobalt would be solid. So what is oxidized and what is reduced? I mentioned that magnesium is going to be reducing cobalt, and then it goes from +2 to 0 here in its elemental state. So when we see the oxidation number goes down, so a decrease in ON, that means something has been reduced. And then magnesium, on the other hand, was 0 and is now +2 over here. So we can say magnesium going from 0 to +2 was oxidized. So we'll continue with our next section in the next video.